Hello, welcome to Learnwizz. It's me, Linus. Hope you are doing well. So all the very best for your exams, coming exams. So in this video, we'll be discussing the most important 20 questions of our topic, chemistry, for CBSE 10th grade. Okay, so moving to the first question. Yes, the first question is, write the balanced chemical equation for the following reactions. Okay, write the balanced chemical equation for the following reaction. After that, you have to identify the type of the chemical reaction. Okay, let us have a look. The first one is, yes, nitrogen gas is treated with hydrogen gas in the presence of a catalyst. Okay, so what is nitrogen? Yes, nitrogen is a diatomic. It is always sitting as N2, diatomic. Plus hydrogen, it's also diatomic. Nitrogen and hydrogen is reacting in the presence of a catalyst. Okay, in the arrow mark you can write out catalyst, and temperature is also given. You can mention it on the arrow below or above the arrow, no problem. And to form ammonia gas, what is the formula for ammonia? Yes, NH3 is ammonia. Yes, then how will you balance this? Right, there are 2 nitrogen atoms in the left side, so put a 2 here. Then total of 6 hydrogen atom, put a 3 here, so it becomes 6. So this is the balanced chemical equation. And see what type of reaction it is. Yes, 2 reactants combined together to form a single product. Yes, this is a combination reaction. Combination reaction. Okay, yes. Moving to the next question. Sodium hydroxide. What is the formula sodium hydroxide? NaOH. Yes, second one is sodium hydroxide. Solution is treated with acetic acid to form sodium acetate and water. Sodium hydroxide is NaOH plus acetic acid is CH3COOH and forming sodium acetate, that is CH3COONA plus water H2O. Okay, yes. So this is already, when we check the number of atoms on both sides, same, right? So that means this is already a balanced chemical equation. And here an acid and a base is reacting, right? So this is a neutralization reaction. To give a salt and water is a neutralization reaction. And moving to the C, ethanol is warmed. What is ethanol? Ethanol is C2H5OH. It is warmed in the presence of ethanoic acid, that is CH3COOH. Gives in the presence of an acid, so H2SO4. Okay, ethanol and acid. So when you hear the word itself, the acid and an alcohol is reacting, what is that reaction called as? You will be getting ester, right? So the reaction is esterification. Esterification reaction, you will be getting the ester. Which ester you are getting here? Yes, CH3COO C2H5 along with water. Okay, here also this is already a balanced chemical equation. And the last one is ethene. Ethene is what? C2H4. It's an alkene. C2H4 is burned in the presence of oxygen. You will be getting carbon dioxide and water. So when you burn some organic compound in the presence of oxygen, when you are getting carbon dioxide and water, what is that reaction called as? Yes, the reaction is called as combustion. Combustion reaction. Okay, this is also, yeah. See here, balancing is not done here. So there are 2 carbon atoms here, put a 2 here. Okay, now hydrogen atoms here 4, so put a 2 here. Now balance the oxygen atom by putting a 3 here. Now it is balanced. So in this session, we have discussed about 4 different types of reactions: combination, neutralization, esterification, and combustion. There are a lot of chemical reactions other, like decompositions, and under the decomposition reaction, thermal, photochemical, electrolysis, etc. coming. Then displacement reaction, double displacement reaction. In the second chapter, we are studying about neutralization reaction. And in metals and non-metals, there are so many reactions to study, like we call electrolytic refining, that is calcination, roasting reactions like that. And coming to the carbon compounds, you have to study about combustion, esterification, substitution, addition, oxidation, that type of reaction. So all these reactions are very important. You have to understand when something is reacting, which type of reaction is taking place. Okay, moving to the next question. Identify the reducing agent in the following reaction. So how will you identify the reducing agent? You have to note down who is undergoing oxidation. Who is undergoing oxidation? Acting as a reducing agent. Okay, moving to the first question. 4NH3 plus 5O2 giving 4NO plus 6H2O. Yes, in this case, oxygen is added to ammonia, right? So ammonia is undergoing oxidation, right? So this is called as what? So ammonia is the undergoing oxidation. So ammonia is oxidized. So ammonia is the which agent? Reducing agent. In the next case, while looking who is undergoing oxidation, it is very difficult to find out. So what you have to do, you have to check down the oxidation number so that you can understand who is undergoing oxidation and reduction. And in the case of F2, it is sitting alone. So its oxidation number is 0. And in the case of HF, you can see oxidation number of fluorine is -1. That means decreased in oxidation number, that is this process is reduction. Okay. So this is reduction process. So this F2 is the oxidizing agent, right? Yes, this is the oxidizing agent because F2 is reduced to HF. So who will be the reducing agent? Automatically, here water will be the reducing agent. Okay. Then the next case, you can see here Fe2O3 plus 3CO gives 2Fe plus 3CO2. Okay, in the case, here you can see here carbon monoxide is acting as a reducing agent because it is abstracting oxygen from this ion. So ion is getting reduced. Okay, here it is getting reduced. So this will be getting oxidized. So who is the reducing agent? Who is undergoing oxidation? CO. So CO is the reducing agent. And in this case, we know it is very simple. To hydrogen, oxygen is adding. So this is undergoing oxidation. So H2 is the what? Reducing agent. Okay. So very simple, but you have to go through the equation very carefully. Okay. Because who is undergoing oxidation, that will act as the reducing agent. And who is undergoing reduction, that will act as which agent? Oxidizing agent. Okay. Yes. Now the next question. A solution of potassium chloride when mixed with silver nitrate. Okay. So potassium chloride is KCl, right? Yes. It is mixed with what? Silver nitrate. What is the formula? Silver nitrate? AgNO3. Okay. So when they mix, what will happen? An insoluble white substance is formed. So we know that two reactants. So automatically this will double displacement reaction will take place and you will be getting AgCl plus KNO3. Right, the chemical reaction involved. Also mention the type of the reaction. And you know this is a chemical reaction of double displacement reaction. Also, we call this reaction as what? Precipitation reaction. Because there is an insoluble white substance is forming, right? Yes, which is that white substance? So, aqueous. Solution of potassium chloride. So, this is aqueous. AgNO3 is also aqueous. And AgCl is the solid form here. KNO3 is also aqueous. And write the chemical reaction involved. Also mention the type of the chemical reaction. Yes, this is double displacement reaction or precipitation reaction. And this is the chemical equation. The white precipitate formed is AgCl. Okay, hope you get it. Next question is ferrous sulfate. Very important question, and this is exactly taken from our textbook. Okay, very simple question. Ferrous sulfate. What is ferrous sulfate? Yes, FeSO4. It is decomposes with the evolution of a gas. having a characteristic odor of burning sulfur. Write the chemical reaction, identify. And we have studied that ferrous sulfate, actually it was green in color. Green color crystals of ferrous sulfate undergo thermal decomposition reaction. Okay, decomposition reaction forming Fe2O3 plus two gases, SO2 and SO3. So these two are gases and this is a solid of what color? Reddish brown color. Reddish brown color. Okay. And yes, ferrous sulfate crystals, we have to balance this, of course, right? 2 FeSO4 gives thermal decomposition Fe2O3 plus 2SO2 plus 2SO3, right? Yes, 2SO2. So oxygen will be what? 4 times 2, 8 oxygen. Here 3. Yes, 336. Yes. Okay, let us move to the next question. Ferrous sulfate decomposes with the evolution of a gas. So this question is exactly taken from our textbook. That is FeSO4. Ferrous sulfate is heating, right? Decomposes means you have to heat that, right? So this is undergoing thermal decomposition reaction. Okay, thermal decomposition reaction. And ferrous sulfate was initially green in color. Green color ferrous sulfate crystals heated, you will be getting Fe2O3, ferric oxide, a reddish brown solid. Okay, reddish brown solid along with the evolution of a gases like SO2 plus SO3. So you can see here ferrous sulfate is undergoing decomposition. Okay, this is a thermal decomposition reaction. You will be getting two gases, SO2 and SO3. Okay, after that you have to balance this equation. Yes, here there are two iron atoms, put a 2 here. Okay, 2 FeSO4 gives Fe2O3 plus SO2 plus SO3. Okay, that is the decomposition reaction. Very simple reaction, right? Okay. Yes. Now moving to the next question. On adding a drop of barium chloride solution to aqueous solution of sodium sulfite. Okay. So let us write down the equation. Try barium chloride, BaCl2. Okay. Sodium sulfite. Sodium is Na2SO3. Sodium sulfite. Okay. They are reacting. You will be getting a precipitate, right? So here automatically double displacement reaction will take place and you will be getting BaSO3 plus what is remaining? Sodium and chlorine, right? 2NaCl. So this is white precipitate that is formed. Okay. Barium sulfite. Write the balance equation. That is what we have written. What other name can be given to this precipitation reaction? Yes, what is the other name of this precipitation reaction? Yes, double displacement reaction. Double displacement. Okay. Then on diluting, dilute hydrochloric acid to the reaction mixture. So what we have get here is barium sulfide, right? BaSO3. Just add hydrochloric acid to this barium sulfide. Okay. So what you will get? You will be getting again barium chloride along with the evolution of a gas CO2, SO2 plus water. Because you have to balance like this. Okay. You can see here barium sulfide was initially white precipitate formed. When you add water to, not water, when you add HCl, dilute sulfuric hydrochloric acid into that, you will be getting barium chloride again. So what will happen? This due to the formation of this barium chloride, which is soluble in water, the white precipitate will disappear. Okay, that is the answer for the C question. Okay, on diluting or adding hydrochloric acid to the barium sulfide, barium chloride will be produced. Okay, that is, it will get soluble in water, which is soluble in water, so that the white precipitate will disappear. Okay. Hope you got the answer. Yes. Moving to the next question. A salt A commonly used in bakery products on heating gets converted to another salt B, which itself is used for the removal of hardness of water. So when you hear the question bakery products, the salt will come automatically to your mind, right? And when you hear the word the removal of hardness of water, the salt will automatically come. So the question is very easy, right? So what is that salt that is used in the bakery product? Yes, it is sodium hydrogen carbonate, NaHCO3. Yes, sodium hydrogen carbonate. When we heat that, what will be getting? We are getting sodium carbonate along with the gases like carbon dioxide and one more product, that is water. Okay, and we're getting another salt B. So this is A and this is B. Okay, and we know sodium carbonate, right? That is using as a washing soda, sodium carbonate decahydrate. That is used for the removal of hardness of water. And a gas is involved. Which is that gas? Yes, the gas is carbon dioxide. Okay, when you pass this gas, carbon dioxide gas, to lime water, what will happen? Yes, it will turn milky. So whenever some gas will turns lime water milky, the gas is always carbon dioxide. So A is sodium hydrogen carbonate and B is sodium carbonate and C is carbon dioxide. Okay, that is turning the lime water milky. Okay. Okay, now next question is just formulas or some salt is given, name is given. You have to identify the base and the acid. Okay. Yes, NH4Cl. NH4Cl is the ammonium chloride and its base is given ammonium hydroxide. So since it is having a negative ion of Cl minus, so its acid will be HCl. Okay. Next is copper sulfate. Okay, copper sulfate. So acid is given. What is the formula of copper sulfate? Yeah, CuSO4. And it is given the acid is sulfuric acid. So what will be the base? It will be COOH twice. Copper hydroxide will be the base. Next is very simple, sodium chloride. Sodium chloride is made from NaOH and the acid is HCl. Next is magnesium nitrate and it is given nitric acid. So what is the base from which magnesium nitrate is formed? Yes, magnesium hydroxide, MgOH twice. Next is potassium sulfate. So potassium means potassium hydroxide will be the base and sulfate, right? So sulfuric acid will be the acid. Next is calcium nitrate given and calcium hydroxide is the base. Since it is a nitrate, the acid will be nitric acid. Okay, so very simple and you can identify what type of salt it is. Ammonium chloride, strong acid and a weak base, like that. You can identify which type of salt it is. It is a strong, it is an acidic salt. Acidic salt. By looking the base and the acid nature. Say is it strong or weak, like that you can identify what type of salt from which that is formed. Okay, yes. Next is a metal carbonate X on reacting with an acid gives a gas, okay, which when passed through a solution of Y gives the carbonate back. On the other hand, a gas G that is obtained at anode during the electrolysis of brine is passed on dry Y. It gives a compound Z used for disinfecting drinking water. Okay, so X, Y, G, and Z you have to find out. Okay, so what is given? Methyl carbonate X. Okay, metal carbonate X gives an gas carbon dioxide. Okay, metal carbonate, which will be that X on reacting with an acid that is giving a gas. Okay, metal carbonate. What is that metal carbonate? Yes, it will be calcium carbonate reacting with HCl, an acid. You will be getting what? Salt plus carbon dioxide plus water, right? Metal carbonates react with acids. You will be getting a salt, right? Salt plus carbon dioxide plus water. Okay. So which gas is that? Carbon dioxide gas. Okay. And when you pass this gas through a solution Y, okay, gives carbonate back. So you have to get this carbonate back. Carbonate means calcium carbonate. So what will be this Y? Y will be a solution of calcium hydroxide, right? CaOH twice. Calcium hydroxide, you will be getting carbonate and water. Okay, so this is X. And what is Y? Y is calcium hydroxide. Okay, yes. On the other hand, a gas G that is obtained at anode during the electrolysis of brine. Yes, during the electrolysis of brine, we are getting two gases, chlorine and hydrogen, right? So when you, which gas is that? You have to do this. Brine on dry Y gives a compound Z. Okay. So in the electrolysis of brine, you will be, I will write the electrolysis of brine here. 2NaCl plus water H2H2O giving 2NaOH plus chlorine plus hydrogen gas. Okay, so what is the G? Gas G. Who will be the gas G? Hydrogen or chlorine? That is passed on dry. Y gives a compound set that is used for disinfecting drinking water. So which gas, which compound is used for disinfecting water? Yes, that is bleaching chloride, right? So to you get the bleaching chloride, for that purpose you have to add which gas? Chlorine gas is passed through dry slaked lime. Okay, that is dry. Y means what? This is what? Yes, this is Y. And chlorine is the G. Okay, and you will be getting CaOCl2. This is Z. Compound Z plus water. Okay, that is this equation is very simple. Just I will read it again. Metal carbonate on reacting with an acid gives a gas which when passed through a solution of Y gives a carbonate back. So we have studied about carbonate. Which carbonate? Reacting with acid giving a gas means carbon dioxide gas. Then carbonate back means it will be a calcium carbonate. Okay, when we pass this carbon dioxide gas to calcium hydroxide, you will be getting this carbonate back. Okay, then electrolysis of brine, you will get in two gases in that, chlorine and hydrogen. You have to pass this chlorine gas through dry slaked lime. Okay, then we getting bleaching chloride. So that is used for disinfecting drinking water. Yes, next question is very simple. Identify the compound X on the basis of the reactions given below. Okay, so compound X is reacting with the zinc and a hydrogen gas is produced. Okay, it is, we know that a metal, zinc is a metal that is reacting with what? Acid or a base. Acid or a base, you will be getting what? Hydrogen gas. Okay, wait. Now, this HCl is an acid. Okay, it is reacting with a compound X, you will be getting a B and water. So acid and a something like, so acid and acid cannot react. So it will be a base. Here it will be a base. Acid and a base react, you will be getting salt here plus water. Neutralization reaction. Okay. And here you are getting acetic acid. Okay. So it will be base here. Automatically we know that it is a base here. Which base will be that? Okay. So it will be NaOH. So NaOH react with the Zn giving what? Na2ZnO2, sodium zincate, and B is NaCl, salt plus water. And what is C? Sodium hydroxide plus acetic acid, CH3COONA, sodium acetate. Okay, that is the reaction. Yes. Now, a non-metal is important constituent of our food. So mainly we are eating carbohydrate, right? Mainly. So carbohydrate contains carbon, right? So yes, organic compound carbon. So that on non-metal A will be carbon, has two oxides, B and C. B is a toxic, and we know carbon dioxide forms two oxides, carbon dioxide and carbon monoxide. And this carbon dioxide is the reason for what? Global warming. And this carbon monoxide is highly toxic oxide. Okay, and to which group the periodic table A belongs? And we know carbon's atomic number 6. It is having 2,4. What 2,4 is electron configuration. So it will be belonging to 14th group. Okay. Now, next reaction. Give the reaction involved during extraction of zinc from its ore by roasting of the zinc ore, calcination. So, while doing roasting, you have to take sulfide ore, and by cancellation, you have to take a carbonate ore. Okay. Then what is the equation? Zinc sulfide plus oxygen, the presence of oxygen, right? Yes. So what will you get? You will be getting zinc oxide. So basically we are getting its oxides along with the evolution of a gas SO2. Okay. 2ZnS plus 3O2 gives 2ZnO plus 2CO2. So that is the roasting reaction. Okay. Then what is happening during calcination of zinc carbonate? Yes, calcination takes place for carbonate ores, zinc carbonate. Okay, zinc carbonate. What will happen? Zinc carbonate is heated strongly in the absence of air, right? Calcination, that is calcination. Yes, zinc carbonate is heated, so we'll be getting zinc oxide plus which gas? Carbon dioxide gas. Okay, so you must know what are the two processes of roasting and calcination. Okay, so roasting is the process where ore is converted. Both are the processes. The ore is converted to respective oxides. Okay, and in the case of roasting, how it is done? Roasting heating takes place in the presence of excess of air. Okay, but in the case of calcination, heating strongly in the absence of air. Okay, and in the case of roasting, you are getting SO2, and in the case of calcination, you are getting carbon dioxide as the gas. Then next question is, yes, explain the following reactivity. Okay, explain the following reactivity. And let us move on to the first question. Reactivity of aluminium decreases if it is dipped in nitric acid. Yes, we know that nitric acid is an oxidizing agent, right? Nitric acid is an oxidizing agent. So what will this nitric acid do? Nitric acid, when we dip aluminium in the nitric acid, a layer of aluminium oxide, Al2O3, will be forming on the surface of aluminium. So as a result, what will happen? Reactivity of aluminium decreases. Very simple, right? So just write down HNO3 is acting as an oxidizing agent. So aluminium will be converted to aluminium oxide layer on the surface of aluminium, which will prevent further reaction. Okay. Next is carbon cannot reduce oxides of sodium and or magnesium. Very important and important. Very important. Okay. Because we know sodium and magnesium are reactive metals, right? Highly reactive metals. So what you have to remember here is that whenever they react with oxygen, okay, whenever they react with oxygen, they are having high affinity to oxygen than carbon. Okay, so these metals are having, like sodium, magnesium, have high affinity to oxygen than carbon. Okay, so that is why carbon cannot reduce their oxides. Okay, next is sodium chloride is not a conductor of electricity in solid state. Yes, of course, sodium chloride is an ionic compound, right? Ionic compound. In the case of solid state, ionic compounds are not very free to move, right? They are not very free to move. So what will happen? Ions are not free, so they cannot conduct electricity. But when we melt it, or when we when we add water to that or make it aqueous, what will happen? The ions become free to move so that they can conduct electricity. Yes. Why these iron particles are galvanized? Because to prevent corrosion, right? To prevent corrosion, iron particles are galvanized by coating it with a zinc. Okay. Then metals like sodium, potassium, calcium, and magnesium are never found in the free state in nature. Yes, because why? These metals are highly reactive metals, right? So they will readily react with air, water, etc. So we cannot get them. They will be forming to their respective compounds like oxides. Okay. Next is given below The steps of the extraction of copper from its ore. Write the reactions involved. Okay. First one is roasting of copper 1 sulfide. Okay. Copper 1 sulfide is Cu2s. Roasting means oxygen and heating. You will be getting what? Corresponding oxide of the metal and SO2. Okay. We have to balance this. Okay. Now next is reduction of copper 1 oxide with copper 1 sulfide. Next reaction, copper 1 oxide plus copper 1 sulfide. You will be getting what? Yes, 6Cu plus SO2. Okay, balancing. Next, what is electrolytic refining? What is the reaction involving electrolytic refining? At cathode, what reaction is happening at cathode? Yes, at cathode, Cu2 plus will gain 2 electrons. Cathode reduction, right? Reduction means gain of electrons and it will become copper. And draw a neat and labeled diagram for the electrolytic refining. Sure question, okay? This is very important and sure question. So you have to put two electrodes like cathode and anode, okay, and mark it as cathode, and this is anode, and cathode is negative electrode and anode is positive electrode. Okay, then you have to make a key and a cell, connect the two electrodes. Okay, and you have to take what? A solution of what? Acidified copper sulfate solution. Okay, in the bottom of this anode, you can see impurities. We call it as anode mud. Okay, so you have to draw a well detailed diagram, and also you have to mention this cathode is pure copper. Okay, pure copper is taken as a cathode, and copper will be deposited. Cu2 plus ions will be deposited in the cathode, and from anode, copper 2 plus will be releasing, and it will be depositing at the cathode. Okay, that is happening, and you have to draw this neat and well labeled diagram. Okay, yes. So identify and name the functional group present in the following compounds. The first one, OH is a functional group, and this is 1, 2, 3. This is propanol. Alcohol is named as OL. And the second one, this is C double bond OH. This is an carboxylic acid. And how many carbon? 1, 2, 3 carbon. So this is propanoic acid. And the third one is only CO, that is, it is a ketone. And what is the name of this ketone? 1, 2, 3, 4, 5. 5 carbon. So this is propanone. You have to mention the position of the propanone 1, 2, 3. So propan 3 on. That will be the correct IUPAC name. And here alkene 1, 2, 3, 4. So bute 1-ene. Bute 1-ene. This is an alkene. Okay. And this is very simple. Match the following. Alcohol, CH3OH and acid is reacting. You will be getting ester. Which reaction is that? Yes, esterification reaction. And here to this double bond, hydrogen is added and double bond is getting converted to single bond. So this is what? Addition reaction. And here CH4 plus Cl2 and CH3Cl, substitution, right? One hydrogen is substituted by chlorine. Next is CH3COO H plus NaOH, acid and a base reacting. Yes, neutralization reaction. Okay, now the next question. How would you bring about the following conversions? Name the process and write the reactions involved. Yes, what is this reaction? Ethanol to ethene. So will it convert CH3 CH2OH. Ethanol is converting to CH2 double bond CH2. Yes. What is this reaction called as? You have to heat this with concentrated H2SO4. So what will happen? Dehydration will take place. Dehydration. Concentrated sulfuric acid is acting as a dehydrating agent. Okay. Next is propanol. CH3CH2OH. Propanol is converted to propanoic acid, CH3, CH2, COOH. So addition of oxygen, this is oxidation reaction. Alcohol will be converted to acid in the presence of KMNO4, alkaline KMNO4, that is oxidizing agents. Alkaline KMNO4 or acidified K2CR2O7. Very important reactions, okay? Very important. Next is an organic compound A on heating with concentrated sulfuric acid forms a compound B. On addition of 1 mole of hydrogen in the presence of nickel forms a compound C. Okay. So organic compound A on heating with concentrated sulfuric acid forms a compound B. Okay, we have discussed now which organic compound will be converted to this one in the presence of concentrated sulfuric acid. Okay, it will be alcohol first. Okay, then what is happening? Yes, then addition of 1 mole of hydrogen in the presence of nickel. So that will be an addition reaction. Okay, followed by combustion reaction is written here. Yes, then identify the compounds A, B, C and write the chemical reactions involved. Okay, so first one will be what? Alcohol, right? Which alcohol will be that? Yes, it will be ethanol, that is CH3CH2OH. Ethanol when treated with H2SO4, when heated you will be getting CH2 double bond CH2. Okay, that is, this is A and this is B. Okay, B is when treated with hydrogen in the presence of nickel, you will be getting what? CH3, CH3. That is C2H6. Okay, what is this? This is C. Okay, and the chemical equations, you have to write down equation one by one. Okay, and this is treating this C2H6 is treating with what? Combustion. Undergoing combustion means oxygen, right? And you will be getting 3 moles of water and 2 moles of carbon dioxide, right? 2 moles of carbon dioxide and 3 moles of water is given. So this is undergoing reduction. Okay, C2H6, right? 7 by 2 O2 plus 2 CO2 plus 3 by 2 3H2. Okay, so this is what? Combustion reaction. So A is alcohol, ethanol, and B is ethene, C is ethane. Okay, next is an organic compound C with the molecular formula is given C2H4O2 reacts with a sodium metal to form a compound R, evolves a gas which turns a pop sound. Okay, so compound A on treatment, C on treatment with an alcohol A in presence of an acid forms a sweet smelling compound S. On addition of this NaOH to C, it gives R and water. S on treatment, the NaOH gives back R and A. So you have to identify CR, okay, CR, A and S. Okay, so first reaction, let us see here. A compound A molecular formula is given. 2 oxygen atom is given reacting with the metal Na. So if it is a 2 oxygen atom organic compound, it will be carboxylic acid, that is CH3COOH. Reacting with a metal, A, Na means what? Sodium. You will be getting what? CH3COONA plus hydrogen gas. That is having a pop sound. Okay. The compound C, again the compound C, CH3COOH, treating with alcohol, which is the alcohol A. What is the alcohol? CH3OH. You will be getting a sweet smelling compound means CH3COOCH3 plus water. Okay, that is, this is an ester, esterification reaction. Okay, yes. Then what is the next one? Yes, so this is yes. So you're getting A and yes. On addition of NaOH to C, okay, C, what is C? Ester, right? Ester to ester, you have to add NaOH. What reaction is this? This is saponification reaction. You will be getting CH3COONA, sodium salt of the acid along with alcohol. Okay. Is on treatment with NaOH gives back R and A. Okay. So which is R? The compound R. Yes, this is R and Yes, this is, yes, all the reactions are completed. A compound C reacts with a sodium metal to form a compound R. And this is a compound, not A, this is C. This is a C compound, AR. R, which involves burns with R, involves a gas. R and involves a gas. Okay, pop sound gas. C is the compound, this is C. Okay. Then, yeah, C on treatment. So this is the C on treatment with alcohol A. So this is the alcohol. You will be getting A, R and A here. Okay. And to draw the electron dot structure and formula of carbon tetrachloride. Okay, and electron dot diagram drawing will be coming for the exam. And what is saponification reactions? Okay. Okay, next see. Write the formula and draw the electron dot structure carbon tetrachloride. Carbon tetrachloride means 4 chlorine atoms. CCl4 is the formula. Okay, how will you draw the structure? Yes, carbon is having 4 electrons. Okay, 4 electrons in its valence shell. And chlorine atoms, right? Chlorine atoms is having 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, here also chlorine. 1, 2, 3, 4, 5, 6, 7. Here also chlorine. 1, 2, 3, 4, 5, 6, 7. 4 chlorine atoms you have to draw. Okay. Yes. And what you have to do? You have to take this like for carbon 6 electrons. Okay. And for this chlorine, like this, for this chlorine, for this chlorine, and for this chlorine. Okay. So the electron dot structure is completed. So sure question, electron dot structure. And what is saponification reaction? Okay. So so to the ester, CH3COOC2H5. So this is ethyl acetate, and we have to treat it with an alkali, NaOH. You will be getting what? CH3COONA plus and alcohol C2H5OH, corresponding sodium salt of the acid and alcohol. So this is long chain carboxylic acid acting as the soap. Okay, so this is saponification reaction, preparation of soap. Okay, next is a salt X is formed and a gas is evolved when ethanoic acid reacts with the sodium hydrogen carbonate. Name the salt X and the gas. Describe an activity and draw the diagram of the apparatus. Okay, so this is the saponification reaction. Okay, so these are the main important questions we discussed. Hope you enjoyed the video. Just go through all the questions very well. Okay, you'll be getting some idea about all the 4 chapters for your exam. Okay, do your exams well. Wish you all the very best for your exams. Okay, see you on the next video. Bye. Thank you. Have a great time.